everyone, welcome to Maths with JB. I want to go through 3 examples today for part 2 of surd identities. So if you've seen part 1, you get the idea of how to solve these surd identities, but basically it's trying to put them in exactly the same format and then equate the parts. Now in part 2, the difference between these questions and part 1 is that we need to rationalize the denominators to get to the right hand side. So with example 1, the first thing you need to do when you see these, you need to rationalize. So let's start from the left hand side and rationalize our denominator by timesing the conjugates of that surd in the denominator there. So 7 plus 3 root 5 over 7 plus 3 root 5. Timesing the top, put brackets. So 4, I'll leave that factorized for now, just in case we can simplify by cancelling. So the bottom bit's a difference of 2 squares, so it'll be 7 squared minus 3 root 5 squared, 4. So 7 squared is 49, subtract 3 root 5, so that's 9 times 5, which is 45. If you're a bit rusty with rationalizing denominators, maybe check out my rationalizing video. So 49 take away 45, so that'll give me 5. That'll give me 4. 7 plus 3 root 5. So over 4. Now the 4s can cancel out. Then you end up with 7 plus 3 root 5. Okay, so let's put them together. So therefore, 7 plus 3 root 5 equals a plus b root 5. Right, so let's equate the parts. So then we've got a is equal to 7, whole number bits, and b is in front of that root 5, which means it has to be equal to 3. b is equal to 3. Okay, that bit there. Right, so that's the first example. The second example, so we've got 2 root 5 on 3 root 5 plus 4 equals x plus y root 5. So again, starting from the left, and rationalize that. So times top and bottom by the conjugate. Minus 4. Okay, so the top bit. The bottom bit is again a difference of 2 squares. So 3 root 5 squared, subtract 4 squared. 3 root 5, okay, let's write the top. So 3 root 5, so that becomes 9 times 5 when you square that. 9 times 5 is 45, subtract 4 squared is 16. 4 squared is 16, so that will give me 45 take away 16, so 29. 2 root 5 3 root 5 minus 4 on 29. So it looks like we can't really cancel anything there, so we have to expand the top so that we can put it in that format. I'll just scroll that up. So let's expand the top. 2 times 3 is 6, root 5 times root 5 is 5, so 6 times 5, that'll give me 30. Subtract 4 times 2 will give me 8, so 8 root 5 on 29. Right, so I'm running out of space. Let me just continue on up here. So what that means is that we've got 30 minus 8 root 5 on 29, and that must equal to x plus y root 5. Now, it's a little bit different because this one's got a fraction, and this one is basically no denominator, it's just a 1. Now, when you get something like this, split that fraction up to make it in that format. Okay, so let's split the fraction up. So you write it as 30 over 29, subtract 8 root 5 on 29. X plus y root 5. And that makes sense. If you think about when you're adding fractions, just very quickly, say for example, if you've got 1 plus 5 on 9, you could write that as 1 on 9 plus 5 on 9. See? So that's basically what I did when I said splitting the fractions up. Okay, so now that's basically the same format. So x has to be equal to that fraction. So x is equal to 30 on 29, and the number in front of the root y, well, that's the fraction 8 on 29. Okay, now just be careful with that sign there. You see this one's got a minus and that one's got a plus. So when you equate the value of y, you have to take the whole thing, including that sign. So y is equal to minus 8 on 29. Okay, so watch out for that sign. Right, so that one's done. The last example, now this one's a little bit tricky and lengthy, so let's have a look at something like this. Now, we've got two square roots there equal to root x minus root y. So the first thing we need to understand is that if you square root a number, it's going to always come out positive. Okay, you're not going to square root something that will come out negative. So that means whatever x and y is, root x minus root y has to give you a positive number. So that right hand side has to end up with a positive number, which means that x has to be greater than y. Okay, let's start this one. Now the first step here would be to square both sides. To get rid of that big square root there, the outside square root. So let's square both sides like this. Square both sides. So the square root and the square, they're opposite operations, so they will cancel each other out. So on the left, we get 9 take away 2 root 14 equals, on the right hand side, we have to expand this perfect square. So root x times root x, so we get x, root x times y, so root xy, and then there's another root xy. So minus 2 root xy, and minus root y times minus root y, so that'll be plus y. Right, so now let's put the whole number bits together on the right hand side. So that will be x plus y. Take away 2 root xy, that's equal to 9 minus 2 root 14. So as usual, we equate the parts of the expressions, so that 9 has to be equal to x plus y, and that 14 inside the square root has to be equal to xy inside that square root. So x plus y is equal to 9. I'll call that equation 1, and xy has to be equal to 14. That will be equation 2. Okay, so from equation 1, I need to make one of these the subject. So we're going to solve these two simultaneous equations by substitution. So from 1, let's say I want to make y the subject. So y will be equal to 9 take away x. And I'm going to substitute that into equation 2. So sub into 2. So you get x, and I put brackets around the whole lot. So 9 minus x is equal to 14. Okay, so expanding this, so 9x minus x squared is equal to 14. We're going to end up with a quadratic, and of course when you're trying to solve a quadratic equation, we need the equation to be equal to 0. So instead of taking the 14 to the left, I'm going to take this whole thing to the right, just to get rid of that negative in front of the x squared there, because a positive in front will make it easier to factorize. So let's do that. So then you get x squared, when you bring that across, minus 9x and plus 14 is equal to 0. Okay, so we've got the equal to 0 bit. So we're going to factorize this. Now, factorizing quadratics, we're going to need two numbers adding to give us that coefficient of x, so minus 9. And the two numbers have to times to give us that constant term, so plus 14. So this is by guesswork. And the more you do this, the quicker you get at looking for numbers, trial and error. It looks like the 2 times to give you positive, the 2 add to give you a negative. So negative 7 and negative 2 would work. So negative 7 and negative 2. Okay, so that would work. So let's put them in brackets. X take away 7 and x take away 2 equals 0. If you do a quick expanding mentally, you would see that you will return that quadratic. That's how you check your two brackets. Now, two things times to give you 0. So either the first product is equal to 0, or the second product is equal to 0, or both of them could be equal to 0. Right, so from there we would get x is equal to 7, or x is equal to 2. X is equal to 7 or 2. So from these from these two x values, we need to go back and find our y. So let's use the first equation because it looks a bit easier to find y from x. So if x is equal to 7, the first number there, let's substitute into 1. Into 1. If x is equal to 7, you get 7 plus y is equal to 9. So then we get y is equal to 2. If x is 7, y is 2. Now, the other x, so if x is equal to 2, we sub into 1 again. We get 2 plus y is equal to 9. So then we get y is equal to 7. So either x is 7, y is 2, or x is equal to 2 and y is equal to 7. Now, these two pairs, if you remember back to what we mentioned about the values of x and y, we said that root x minus root y has to be a positive number because you can't square root something on the left and get a negative. Okay, it has to come out positive. So that means whatever x or y is, x has to be bigger than y. So if you look at our two pairs, we have to take the first pair, not the second one, because that's when x is greater than y. Okay, so we say, but x has to be greater than y, so therefore x is equal to 7 and y is equal to 2. Okay, so that would be the correct answer. Okay, so I hope that helps with your studies, and that's it for now. I will see you next time. So bye for now.